So what we have H psi n L m is equal to En and psi n L m, where En is nothing but minus m upon 2h cut square and E square by 4 pi epsilon naught whole square 1 upon n square, which is actually equivalent to minus 13.6 by n square electron volt. And we have n is equal to 1, 2, 3, and so on. Okay, so this is our general solution for hydrogen atom. And m is mass of electron, E is charge of electron, and h cut and epsilon is well known, Planck constant and permittivity. Now, what is your psi NLM? So your psi NLM is now radial part R and NL as well as Y LM theta phi. Y LM theta phi is just basically your spherical harmonics. We all know that angular momentum is conserved. So Y LM will be the solution, will also solution. And what is RNL? So RNL is some algebraic function that is known as Laguerre polynomial. So R as a function of L into e to the power minus R n a naught. And you have some initial constant, some normalization constant a is also there. Okay. So this is your radial wave function. And the value of n is obviously from 1 to 3 and so on. And this is algebraic function, and this is all about exponential function come into picture. And this RNL will take care of V rho as well as your rho to the power L plus 1. So I will just give you just two, n is equal to 1 and n is equal to wave, the radial part of the n is equal to 1 and n is equal to 2. Otherwise, in the examination, they will give you the equation. So don't worry about that. So let's try to go for this particular thing. So, and I am just giving you the normalized part also. If you want, you can just remember it. Okay. So what is your R10? Your R10. What is meaning of 1? N is equal to 1, L is equal to 0. So if n is equal to 1, L must be equal to 0 because your quantum number will vary. We have seen into the last class that n will go from 1, 2, 3 and so on. L will go from 0, 1, 2, 3 and n minus 1. We have seen that thing. And m will be obviously from minus L to plus L. We have done earlier, but here we have one more constraint that L will go to up to n minus 1 limit. Okay. So obviously if n is equal to 1, so if now you can see if n is equal to 1, then L must be equal to 0, then m must be equal to 0. And when you have n is equal to 2, then you have L can be 1, L can be 0. When L is equal to 1, your m can be minus 1, 0, 1. If L is equal to 0, you have that particular thing. Okay. And when your L is equal to 0, then it is bound to be that m is equal to 0, and that is actually a spherical symmetric wave function. Okay. So that is a spherical symmetric wave function. So let's try to go for some basic radial wave function as well as probability density. So the first one is 2 upon a naught 3 by 2 e to the power minus r upon a naught. Here, this algebraic part is just 1. Okay. So this is the simplest one. And what is a naught? A naught is nothing but the bore radius. A naught is nothing but what? Bore radius. So you can easily calculate, and this bore radius is something 0.53 angstrom. And you can write it, this bore radius, in term of E, M, and all this thing. We will just give you what is that particular thing. So this is your R10. And what is your radial probability density for R10? So radial probability density, that is 10, is R square R10. And this is nothing. If you will plot, this will be something like this. Okay. We will do problem, then we will also calculate it. But right now I am just giving you all the formula. So there is only one shell is possible, and here we are not introducing the spin of particle. If you will take the spin, then obviously plus half and minus half will automatically come into picture. But right now I am not taking the spin. That is very obvious. Okay. We are just talking about right now for the radial part. Okay. This is your R10. What is energy associated to this one? It's something minus 13.6. Now, let's go for, and this is for n is equal to 1. This is for n is equal to 1. And what about n is equal to 2? So if you have n is equal to 2, then obviously L must be 1 as well as L must be 0. So first I will go for n is equal to 2 and L is equal to 0. N is equal to 2, L is equal to 0. So this is your radial part R20, and the wave function is, radial wave function is 1 upon 2 A naught to the power minus 3 by 2, and you have 1 minus 1 by 2 R upon A naught e to the power minus R upon 2A naught. So now you can see from this particular part, you can easily identify what is value of n. Here n is equal to 1 and here n is equal to 2. Okay, so you can easily identify what is your n. And from where you will find what is your L? From the cos theta part. Remember, for the spherical harmonics, cos theta and sin theta part. And how you will know for m? E to the power im phi. So we have all discussed this particular thing. So if you have this particular wave function, then R20 versus R, you can just try it. You have, you will start from some, and if you will plot it, this will be something like this. Okay. This type of plot, R10 versus 0. Okay. Sorry, versus R. Okay. Okay, good. Now, what will be R20? Your R20 will start from here. It will go down and something like this. But when you will go for the probability density, then your probability density is very interesting. So rho 20. What is rho 20? You have to multiply with R square and then you have to go for this. Then you have something like this. This type of thing is there. And you have, this is maximum at here A naught, and this is maximum at here 5A naught. And here for the ground state, you have maximum at A naught. Okay.
Sir, sir, while calculating the probability density, R10 whole mod square ये नहीं आएगा?
आएगा, बिल्कुल आएगा. ये तो आपका 20 के लिए किया है मैंने.
सर ऊपर में जो 10 के लिए.
कहाँ पर बात कर रहे हो?
सर रो 10.
ये तो क्या R स्क्वायर? हाँ, मॉड स्क्वायर आएगा ऑब्वियसली. गुड, ये आएगा. हम लोग इस पर प्रॉब्लम करेंगे, डोंट वरी. इसे कैलकुलेट करेंगे, पूरा प्लॉट करेंगे. जस्ट अभी मैं आपको इसलिए दे रहा हूँ, जस्ट यू हैव सम ऑल इन्फॉर्मेशन. इसके बाद हम सारा कैलकुलेशन भी करेंगे, डोंट वरी. ठीक है, कुछ भी छूटेगा नहीं. नाउ नेक्स्ट इज n is equal to 2, L is equal to 1. We have R21 and this is basically 1 upon root under 24 a naught to the power minus 3 by 2. You have r upon a naught exponential minus r upon 2a naught. Okay, so you have this sort of wave function. इसका plot कैसा होगा? Which type of plot you have?
इस फंक्शन में cos थीटा नहीं है ना, तो हम पहले
अरे
कैसे?
भाई आप अभी cos थीटा के चक्कर में क्यों पड़े हुए हो?
नहीं, L का वैल्यू समझ।
आप अभी cos थीटा के चक्कर में क्यों पड़े हुए हो? cos थीटा तो इसका पार्ट है, और इन दोनों के बीच में कल मैंने दिखाया कि वो n और l के बीच में रिलेशनशिप तो है ही।
हाँ सर।
ठीक है ना? इसका प्लॉट कैसा होगा? एनीवन? ऑब्वियसली you have something like this. R is equal to 0 पर क्या होगा? ये 0, and you have some maximum and something like this. Okay, R20 versus R. And what will be the probability density? The probability density is also something like this, and this will be maximum at 4a naught. Okay, this is rho, sorry, this is 21 rho 20. So this is your all the radial part of wave function. आपको इतना याद रखने की जरूरत नहीं है, but you have to always take care. अब हमें ये सीखना है कि सब हम कैसे निकालेंगे and how we will go for this. Clear है ये? And now let's try to discuss what will be the degeneracy and what is ionization energy and how we can see all these things. यहाँ तक clear है ना? This is just a fact. ये just fact है. चलो. Now, what we have this as a effective potential. Okay, V effective versus R, something like this. What is your ground state energy? Your ground state energy is minus 13.6 electron volt. What is your first excited state energy? क्या होगा first excited state energy? Minus 13.6 by 2 square. So this is your E2. That is minus 3.4 electron volt. So this is your minus 3.4 electron volt. What will be next one? Minus 13.6 by 3 square. That is 9. कितना आएगा ये? Is that minus 1.5? है ना? चेक करो तो जरा. आ रहा है?
Yes, sir.
Yes. So what you will see a very interesting pattern. Next level is what? This is nothing but what? Minus 1.5. The interesting pattern is there that as you are moving upward, the difference between conjugative energy gap is going to decrease. Isn't it?
Yes, sir.
इन दोनों के बीच का गैप कितना है? That is 10.2. This is very famous number. 10.2 electron volt means if your particle is here, you want to go to first excited state, you need to give 10.2 electron volt to the hydrogen atom in any form, then your particle will go to here. If you will go for second to third, then how much energy you needed? Minus 3.5 minus 1.5. Sorry, final minus initial. So minus 1.5 minus 3.5. कितना देना पड़ रहा है हमें?
1.9.
Sorry, 3.4. So you need to give 1.9. So this much of energy you have to give such that your particle will go from here to here. So you can see in this particular system, the energy gap is going to decrease. So what you will find something like continuum level at this particular point, at this particular level. Something like continuum level, but they are not actually continuous. You will learn these all things in a atomic physics when you will go for fine structure and hyperfine structure. Here we are not introducing lot of extra calculation such as LS coupling, such as some more nuclear, what is effect of nucleus or what is effect of basically proton. And now we are not using that particular thing. But in general, if you are taking up to n level, up to this level, then obviously you will find the continuum level here. Now, what is meaning of ionization energy? Meaning of ionization energy. In the meaning of ionization energy means your particle is at ground state. If your particle is in ground state, then what is meaning of ionization energy? And you give the minimum energy. Ionization energy is minimum energy such that electron will unbounded. So that means the electron will come into this level. So it have to cross all this thing and we have to go for this level. So what will be ionization energy? So ionization energy is EF minus E1. What is EF here? You have to give the minimum energy. So what is EF? Anyone?
Infinite.
Ground state.
Infinite?
Ground state.
Zero. EF is zero. What is final level? That is zero. And what is initial level? Minus 13.6 electron volt. And this value is equal to 13.6 electron volt. So if your electron is at ground state, and you are giving the amount of energy, minimum amount of energy, 13.6 electron volt, it will become unbounded and it will become free. But and this energy is positive, that means you are giving energy to the hydrogen atom, you are giving energy to the system. So this is your ionization energy. So ionization energy just what is E1? E1 is basically minus 13.6 by 1 square, that is minus 13.6. So ionization energy is just a negative of your ground state energy if you want to ionize your particle from your ground state. Okay, so this is very interesting. Now let's try to come to degeneracy of each level. So what you have? You have basically for the given value of L, for the given value of L, I am just talking about one particular state. What will be degeneracy for the given value of L? बताइए, पढ़ चुके हम लोग. What will be degeneracy for the given value of L? 12 plus 1. कुछ भी मत बोलो भाई. The degeneracy is basically 12 plus 1. And if you are going to sum of this all possible value of L, and n will be from 1, sorry, L will be from 0 to n minus 1, then if you will go to calculate this one, this value, L की value कहां से कहां जाएगी? 0 to n minus 1, and this value is n square. So this is degeneracy n square when we are not including the spin. but electron is a spin half particle. So obviously, and this is without a spin, है ना? Without a spin. And hence it is a spin half particle. Then you will just go for 0 to n minus 1. This is 2l plus 1. And we have to multiply due to spin. किससे multiply करें इसे?
2s plus
2
1.
से 2s plus 1, but s is equal to half, so you have to multiply with 2. Very good. So this value is equal to what? 2n square. So this is degeneracy with spin. Now you can see, if you have n is equal to 1, how many electron can be adjusted there? Two electrons. Okay. So now you can put n is equal to 1, you have 2 electron. And this is nothing but 1s2. है ना? ऐसा ही तो होता है. Isn't it? But right now we are just talking about, अगर आप इलेक्ट्रॉन के बारे में बात कर सकते हो कि किस लेवल पे कितना होगा इलेक्ट्रॉन, so that can be calculated from here, 2n square, है ना? So this will just give you the atomic structure of another thing, another atoms also, but I am not going to that level right now. So this is all about your structure here. Okay. So suppose n is equal to 2 लेते हैं, then what is meaning of that? क्या मतलब है? n is equal to 2 लेने का क्या मतलब है? That is 8 is there. What is this 8 number? ये क्या है 8 number?
Maximum 8 electrons will be.
Okay.
N is equal to
Maximum 8 electron can be there. For n is equal to 2, there is 8 type of shell is 8 type of state is there. Quantum state can be possible. क्या क्या हो जाएगा 8 टाइप का? अगर आप देखोगे तो n is equal to 2, you can easily go for L is equal to 0, L is equal to 1, and further you can break it, M is equal to 0, and you have half minus half, and here you have minus 1, 0, 1, and you can further break these two, these two, these two. So how many state is there? Minus half, half, again minus half, half. So how many there? 1, 2, 3, 4, 5, 6. है ना? 6 is there, 2 is there. So there is 8 number of state. Are you getting my point?
Yes, sir.
So you will write something like your state, quantum state, something like this. You can write your quantum state 2, 0, 0, half. 2, 0, 0, minus half. This one, this one. Again, you can just go for this one. Are you getting my point? So you can write your, and every state has same energy level. इसकी एनर्जी कितनी है? -3.4. इसकी एनर्जी कितनी है? -3.4. Suppose I just want to write about this one. तो कैसे लिखेंगे इसे? You will just write all the possible quantum number 2, 1, -1 plus half. You can write in this way. So there is 8 different state which has same energy eigenvalue. That is -3.4. So why degeneracy is something like 2n square if you are including the spin. But if you are not including the spin, then obviously n square will be the picture. Okay. So this is all about the degeneracy of your quantum of your hydrogen atom. Clear है ये?
Yes,
चलो
sir.
चलो. So let's try to go for some basic problem. So आज की क्लास अभी और कल की क्लास में सिर्फ प्रॉब्लम्स करेंगे. So I will just start from the ground state. So and we will discuss all about the ground state first, and then we will go for next level. Okay. So the ground state radial wave function R10 is given by a e to the power minus r by A naught. So first question is, find the value of A such that R10 is normalized. Second question, we have to just write psi 100. What is the expression of psi 100? And then we have to just go for, we have to just find most probable distance. Most probable distance. And we have to plot probability density. Okay. So let's try to go for this. So how we will go for the value of A? We have to go for R10 mod square R square dr from 0 to infinity must be equal to 1. And from here we have mod A square 0 to infinity e to the power minus 2r A naught R square dr must be equal to 1. You can use gamma integral, है ना? एक मैं करके दिखा देता हूं, फिर नेक्स्ट सारे प्रॉब्लम को हम लोग डायरेक्ट लिखेंगे, है ना? What you will do? You will just write 2r upon A naught is equal to t. So what is your r? R is equal to A naught by 2. Then what is your dr? A naught by 2 dt. Oh, shit. चलो